Hi, Assalamualaikum. My name is Intan Fariza binti Muhammad Fauzi.
My name is Nadea Hartinie binti Muhammad Badarudin.
We are from College Kemahiran Tinggi Mara Ledang.
We will present to you our project IoT Smart Monitoring System for IV Drip using Blynk IV+.
IV therapy, also known as intravenous therapy, is the administration of delivering nutrient and hydration directly into the bloodstream for intermediate absorption and use by the body. IV therapy is the fastest way to deliver nutrients throughout the body because it bypasses the digestive system and goes directly into the organ, resulting in a 90 to 100% absorption rate. IV therapy is used for several purposes including hangover relief, cold and flu relief, athlete performance recovery, immunity support, inflammation, digestive issue, and absorption. Here we are trying to improve the existing system by placing 3 sensors on the IV drip bottle to signal the water level in the IV drip through the Blynk application in several types of conditions, which is normal, warning, and critical. These show progress in IV drip therapy and provide facilities for medical staff to get notification for changing IV drip bottle through the Blynk application. Our problem statement came along with our goal is to make employees change IV drip bag on time to avoid IV drip complications such as hematoma, infiltration, and air embolism. An air embolism, also called a gas embolism, occurs when one or more air bubbles enter the vein or artery and block it. When an air bubble enters a vein, it called a venous air embolism. When an air bubble enters an artery, it called an arterial air embolism. These air bubbles can travel to your brain, heart, or lung and cause a heart attack and stroke or respiratory failure. Other than that, we want to lighten the burden of employee, which is nurse or doctor, and to utilize the time nurse and doctor instead of monitoring the IV drip bag all the time. As for our objective that we want to achieve, there are 3 objectives in our project, which is first to develop smart monitoring system for IV drip to notify user through Blynk. Other than that, to identify water level, which is normal, warning, and critical condition in IV drip. And last is to display IV drip level on computer and phone. Then there is a variable in the objective, which is for objective 1 is to notify user, objective 2 to identify water level, and objective 3 to display on computer and phone. As for our scope and limitation, the device using only for 1 liter IV drip bag, useful for hospital staff by get the notification on Blynk only with the same medium such as email, and widely used at emergency department and isolation department.
This is block diagram consisting of input, process, and output. For the input section, there are 3 sensors that represent the water level, which is sensor 1 for normal condition, sensor 2 for warning condition, and sensor 3 for critical condition. The process section consists of an ESP32, which is connected to an input that has 3 sensors and an output that have 3 LED. The output section, there are 3 LED that will light up according to a certain water level, which is green LED for normal level, a yellow LED for warning level, and red LED for critical level. And they are connected to Internet of Things, which is Blynk on the phone and computer to generate notification to the user. This is wiring diagram. This is flowchart of this project. First of all, we must start with connect ESP32 using Wi-Fi to Blynk. If the water level is normal, the green LED will light up. Otherwise, the green LED will turn off. And if the water level drop to a warning state, and then the yellow LED will light up. And if the contrary, the yellow LED will turn off. And if the water level is getting lower, in critical condition, the red LED will light up and then end. The hardware used for this project consists of 3 non-contactless sensors. The function of non-contactless sensor is have the ability to function without need to physically touch the object being monitored. Other than that, the hardware that has been used is Node MCU ESP32, lithium battery, broom holder, IV drip, and 3 LED, which is red LED, yellow LED, and green LED. The software used for this project is Arduino IDE, which is functioned to compile coding and Blynk to notify user about the water level.
Here is how to use IV+. Water level notification will appear on phone and computer display at the same time. First of all, open the door and put IV drip back in the casing. And press switch button to turn on ESP32. The green LED will light up and the user will get notification from Blynk. Here is the water level notification in normal condition. When the water level notification in a warning condition, the yellow LED will light up. Last is when the water level notification in critical condition, the red LED will light up.
To prove the objective we want, we have made various experiments several times. Among them, to ensure that the LED used light up in line with the water level that has been set. For example, green LED for normal condition, yellow LED for warning condition, and red LED for critical condition. As everyone knows, in the table, there are a pass or fail that represent whether the sensor can detect water or not. And all these experiments want to test the green LED specifically. So the following table shows several times the sensor failed to give an accurate reading, causing the LED to light up incorrectly in sequence. For example, table experiment 2 at water level column represent the non-contactless sensor used. If the critical sensor failed to detect water, then the green LED will not light up, because if you want the green LED to light up, all three sensors need to be exposed to water. So we need to identify the cause of the problem and solve the following problems, including jumper wire that do not follow industrial standard and sensor that need to be prepared to get used the presence of water. After several attempts, we managed to get the best reading. We used the same experiment to test for yellow LED and red LEDs.
This was carried out by doing several experiment trials. Based on the observation obtained through the experiment, the component ignite and react faster. This is because the component get direct wire connection with the controller, which is ESP32. The time taken for the LED to light up is faster than the notification on the phone and computer. We found that the time taken for notification to appear on the phone and computer screen is longer than the component, because there is unavoidable problem, which is internet problem, and between the Blynk and the controller lost connection. There are 4 improvements in this project, which is number 1, put LCD to display the condition water level, which is normal, warning, and critical. Second, this project can measure flow rate and volume of water level in IV drip. Third, put a buzzer that produces a sound according to water level, which is start slowly for normal level and loud for critical level. Last but not least, use a lighter material to make up the casing. For the conclusion, with the help and guidance from our supervisor, Encik Ahmad, Azmeer bin Azman, and cooperation all of us as a groupmate, we are able to complete our final year project IoT Smart Monitoring System for IV drip using Blynk with successful. We are able to learn and know how to use Arduino IDE and identify coding problems. We also learn how to make the resulting coding and connect to Blynk on phone and computer. Besides that, we also can explore way to create Blynk via web page. So on, we also can learn and share opinion about casing with people who are more experienced to come up with various ideas for making casing before getting an ideal casing for use in hospital to make it easier for users such as nurses and doctors. With our final year project, which is IoT Smart Monitoring System for IV drip using Blynk IV+, we are sure that this project can help the health field, especially doctor and nurse, to ease their burden from monitoring IV drip all the time with the internet of things, which is notification from Blynk on phone and computer. Besides from that, the manufacture of this project can prevent and reduce IV drip complications such as hematoma, filtration, water embolism, which is can cause death. In addition, it can reduce treatment costs, which is more expensive than regular treatment. Time can also be deducted from recovery treatment. Last but not least, the cost of making this project is very reasonable and cheap. So with that, we hope that this project can be developed and updated for future improvement so that it becomes medical tools that can be used for hospital and clinic use.